Good afternoon, friends. This is Kami here. We're going to look at a dose response chart that we saw last time we met each other in the classroom. I missed those times. And this dose response chart came to us from a variety of sources spanning the years from 2001 to 2013. And in that, it provided us with an effective dose for 10%, 50%, and 90% of the population. In other words, ID10, ID50, and ID90. You have correctly spotted the fact that these numbers have large ranges. Large ranges are only associated with large uncertainties. Theoretically, you only need one spore for the onset of anthrax disease in an animal or human. However, for the purpose of estimation, this is the data that has been accumulated over decades, and that's the tool we have for an estimate. So, if we were to assume for an ID50 from EISD of 2013 showing us a range of 7,200 to 17,000 in an arena that sits 10,000 people, an ID50, if those ID50 numbers of 7,200 plus could be maintained, 50% of the 10,000 people in that arena will be very hard hit. That is equivalent to 5,000 people or more, or a little bit less. Let's turn our attention to strains of anthrax. And now you are very well knowledgeable about the meaning of the word strain. In other words, the genetic coding of anthrax bacteria, and that genetic coding is in the arrangement of base pairs in its DNA. There are three broad categories of anthrax bacteria, ranging from non-virulent, in other words non-toxic, to extremely toxic or megatoxic, and in between. Well, Ames is a well-studied strain, and that's a very highly virulent strain. Stern is a non-virulent strain. And guess, folks, yes, its geographic location in Canada, and that's a good thing. Why? Because this is non-virulent. It's a base for development of anthrax vaccines. That's a very good thing. Therefore, its genetic information in the DNA is different. Volum is a low virulent strain. So, again, the genetic code imprinted in the DNA is different. Russia and the United States were in possession of many genetically engineered strains of anthrax that were ranging from megatoxic to gigotoxic, toxic, or even terotoxic by genetic engineering and modifying the DNA sequence of anthrax. Now, how is it that, for instance, the Stern, the non-virulent strain, does not cause any anthrax disease? The answer lies again in the genetic coding of the DNA. So in that genetic coding of Stern, you have the tripartite toxins PA, EF, and LF. What you're missing in that genetic information is the capsule. that helps the anthrax bacteria to evade the white blood cells. That capsule is missing, therefore making this strain of anthrax non-virulent. Now I want to turn my attention to decontamination of anthrax. Yes, we do have a few weapons in our arsenal, some better than others, so let's start. You have all heard of hydrogen peroxide, available in your local drugstore, and if it's applied in a vaporous form, it is efficient to some extent in extermination of anthrax spores. However, its efficiency is not at a level that will be satisfying. But the big gun in our arsenal of finding anthrax spores is chlorine dioxide gas, also referred to as CD, that is effective against viruses, bacteria, and last but not least, spores, anthrax spores. But we need to set up parameters as how the chlorine dioxide gas, which is sporicidal, meaning it kills spores, is deployed. So look at this with me, and you will see the CD gas in a building contamination scenario. So in order for us to succeed in this venture, you need to maintain 9,000 plus parts per million by volume per hour. And you're familiar with the expression parts per million, and in mathematical form that is referred to as ppmv, parts per million by volume per hour. In order for CD gas to reach its maximum destruction of anthrax spores, we need to raise the interior temperature and humidity of that building or structure. We are looking at temperatures north of 24, and some people even recommend 26, and high humidity of minimum 75%. Now, if that structure inside the building has porous structures, in other words, wood, cinder blocks, and cement, these structures are porous, so they require a longer treatment by chlorine dioxide gas, the CD gas. And the success of this operation is tested after a certain period of time, where people suited properly go inside and take spore samples to see what is left. Let's look at a typical calculation, and in this calculation, again, we visit the concept of CT, concentration times time. You have seen that earlier on in the course with vaporous chemical weapons. CT, concentration times time. So let's look at this together. Concentration times time is CT. So concentration as presented by parts per million in volume times hour is presented as parts per million by volume times hour. Now, in a perfect world, we desire a 9,000 plus ppmv.h. In actuality, in a best case scenario, because of the nature of the building, whether they're leaking really bad or not, we can get only at best 1500 ppmv/h, or even as low as 900 or below ppmv/h. So what is the approach in here? Let's look at that. What is the scenario? The scenario is an old army warehouse built out of cinder block walls and large wooden storage structure. When you hear cinder block and wooden structure, you have to think porous structures. Action. The chlorine dioxide gas is hooked up, the heaters are fired up, and the humidifiers are started up. And after 2.5 hours of start of the operation, our gas concentration indicators tell us that we have a steady state concentration of 1000 ppmv. So, what is the way forward? Well, the initial 2.5 hours is deemed completely ineffective. That is our ramp-up time. However, in order to reach the desired sporicidal concentration times time of 9000 ppmv hour, we will need a 9-hour or more of the achieved 1000 ppmv that our gas detectors inside the building were indicating to us. 9 hours is an absolute minimum. The recommended time sometimes is a factor of 2 or 4. So in the case of factor of 4, you're talking about 9 times 4, 36 hours of the chlorine dioxide gas maintained at that humidity and temperature. After that, again, we will assess the spore count by spore strips and we will make a decision. Thank you for your attention. See you soon.